Hello friends, welcome back. Today we are solving another interesting problem, Koko eating bananas. Koko loves to eat bananas. There are n piles of bananas represented by the array piles, where piles of I is the number of bananas in ith pile. The guards have gone and will come back in h hours. Koko starts eating bananas while the guards are gone, and Koko can decide the speed at which she wants to eat the bananas. Let's call this speed k. Each hour, Koko chooses some pile of bananas and eats k bananas from that pile. If that pile has less than k bananas, she can only eat that many bananas even though she still has some more time left to eat more bananas. So basically, Koko has to stick to that pile for that specific hour. In the same hour, she cannot eat bananas from two different piles. On the other hand, if the pile has more than k bananas, she can only eat at most k bananas. We have to find the minimum speed k such that Koko can eat all the bananas within the k hours. So basically, we have to help Koko pick her speed, k, such that she can use as much of h hours as possible before the guards can come back. In other words, we have to maximize time as much as possible without going over h hours. Let's look at this example. In this example, the maximum speed at which Koko can eat bananas is the maximum value in the array piles, which is 11, because even if we chose k greater than 11, there are no piles with more than 11 bananas, so at most she can only eat 11 bananas. That's why max value of the piles array is the upper bound for the speed k. So if we chose k equal to 11, that means it takes 4 hours to eat all the bananas. But we want to maximize using almost all of the 8 hours as possible. By picking 4 as the speed, it takes 1 hour to eat the first pile, takes 2 hours to eat second pile, 2 hours to eat third pile, and 3 hours to eat fourth pile. In total, Koko takes exactly 8 hours. That's why answer is 4 here. Similarly, in the second example, the max speed is 30 because that's the maximum amount of bananas in any pile. If we set k equal to 30 in this example, it takes 1 hour each for each pile, and the total is 5 hours. Hence the answer here is 30. From these examples, we can learn that max value of k will be max of array piles. And the minimum value obviously will be 1. Koko can choose to eat just a banana in each hour. So within this window will be our optimal speed. So what if we tried every speed starting from 1 all the way up to the maximum value of piles, and we find what's the minimum speed we can pick and still ensure Koko can eat all the bananas in h hours. Once we find a speed where this is not achievable, we can stop this search. So the runtime of this algorithm will be O of n because we have to search through all the piles for each speed, and there will be total m possible speeds where m is the max value of piles. If you think about it, we do not have to check all the values of speed in this window. We know that value of k will be somewhere between 1 and m. If we pick the speed m divided by 2, and if Koko can eat all the bananas in all the piles, that means any speed greater than m by 2, Koko will be always able to eat all the bananas because we are increasing the speed. So we don't have to search the right half. On the other hand, if Koko cannot eat all the bananas at the speed m by 2, any speed slower than that, she would still not be able to eat all the bananas, so we can ignore the left half. For each speed we tried, we can either ignore left half or the right half, based on whether Koko can eat all the bananas or not. And we can continue to do so until the window collapses to just one speed, and that speed will be our final answer. And this algorithm we just described is binary search algorithm, and the runtime for this now will be big O of n log m. Log m because for each speed we test, we get rid of either the left half or the right half. Hence, we bring the complexity down from m to log m. And that's our final algorithm. Let's write code for this algorithm. We know that the minimum speed we can pick is 1, and the maximum speed we can pick is the max value of piles. And we have to binary search our answer in this window. So while this window has more than one speed, we find the mid element in the window, which is r minus L divided by 2. We check if Koko can eat all the bananas at this speed. If so, she can obviously eat all the bananas at speed greater than k. That means we can get rid of the right half. So we set right equal to k. Else, we get rid of the left half equal to k plus 1. We didn't do k minus 1 over here because we know that at speed k, Koko can eat all the bananas. In the worst case, this itself could be our answer. So our window could narrow down to this speed. So we want to keep at least one speed in the window that works always. That's why we don't do -1 here. Finally, once we have explored all the speeds and the window has only one speed left, we just return that speed. We haven't defined this function canEat. Let's define it. CanEat takes speed as input, and we have to calculate the total time needed to eat all the bananas in all the piles. So we check for each pile, time taken to eat that specific pile is time equal to the number of bananas, which is pile, divided by speed. Let's say the current pile has 12 bananas and speed is equal to 5 bananas per hour. At this speed, in the first 2 hours, Koko can eat 10 bananas and she will be left with only 2 bananas for last hour. Even though she can eat 5 bananas in the last hour, she can only eat 2, and the remainder of 0.6 hour, Koko does not eat any bananas, which implies she takes total 3 hours to eat 12 bananas. So we have to round this time up. It's basically math.ceil pile divided by speed. So we add this time to the total time and we return if total time taken to eat all the bananas is less than or equal to h hours, which means Koko can eat all the bananas. That's our code. Let's try to run this code. As you can see, the submission went through. If you like my work, please support by liking the video and subscribing to the channel. I will see you in the next video. Thank you.